Hey everyone, this is going to be lesson 11 on our Energy Skate Park PhET lab. So this is going to be a virtual lab kind of going over different parts of energy that we talked about in our previous lessons, like potential energy, kinetic energy, and then the law of conservation of energy. All right, so we're going to be using this particular lab. A couple different ways you can get to the lab. You can click on this link, or you can simply just type it into your URL. All right, once you guys click on it, you'll get to a page that looks like this. We have a few different sections to this, so you can kind of play around for the first little bit if you want. But I'm just going to go ahead and skip right to playground. All right, now the playground, you guys have a few different features here. Kind of that first step is just looking at what can you change about this particular simulation, right? So just kind of play around with it. What are some of the things that you can manipulate, right? Click here to type. Now, on the track of your choice, right, you just kind of create your own track. The way you can do that is you just pull up these different parts. You can kind of manipulate the size, shape, angle, etc. You can pull pretty much an unlimited number of these tracks and then just connect them. Right, just, again, set up however you want. To actually get the skater on the track, go ahead and click on the skater themselves, place them on the track. Let go, and then they'll just kind of go up and down your track. If you want to kind of just restart it all, just hit the restart button, or restart arrow, I should say. All right, so once you've kind of designed your track the way that you want it, let's get at least 2 different track pieces out here. I'm going to make a little funky half pipe here. There you go. So I got a little funky half pipe. A couple of things I want to do is I want to change the settings. So I want my settings to match the settings of this picture, right? We want to see the pie chart, we want to see the bar graph, and we want to change friction to be none, right? And we'll talk a little bit about friction later on. All right, so I'm going to click pie chart, I'm going to click bar graph, I'm going to switch friction all the way to none, and then I'm going to place my writer here. I can start seeing what's going to happen. All right, so I'm seeing some energy transformations happen in 2 different views. All right. So we want to look at what are the 3 types of energies we see in both the pie chart and the bar graph. We can go ahead and write what they are and just kind of a simple definition of them. All right, so that's just our intro, right? Now we're getting into kind of the nitty gritty of energy transformations. So once you've created your track, identify any 4 points on your track. So basically any 4 of these dots. You see I got 5 here, so I just want to choose any 4 of them. All right. So what I want to do is I want to make a prediction of what I think the energy pie chart will look like at these 4 points, right? So let's say point 1. Pause my writer, take them off. At point 1, when he's all the way up here, I want to make a prediction. What do I think the potential energy will look like? What do I think the kinetic energy will look like? You can even think about thermal if you want, but that's not necessary. Okay, prediction, when you run your simulation, what's it actually? And what are the differences between your prediction and the simulation, if any, right? If there's no differences, you can just leave that blank. So do that for all 4 of your points. All right. Again, to question 3, we know in our last lesson we talked about the law of conservation of energy, that energy cannot be created or destroyed. It can only transform to another type. So we want to look at just some basics, right? What type of energy do they have when the skater is at the highest point? What type of energy do they have at the lowest point? Again, it can be more than one type of energy. And then what was the transformation? Like what happened? How did we go from one type to another if that happened? All right, in part two, we're going to be using this little diagram here to answer the question. All right, we want to make some predictions. So in this one, it's a little bit of a funky track. We got 5 different points, A through E. We just want to identify at which point is our skater meeting this description. So at what point, A, B, C, D, or E, are they at their maximum speed? At what points do they probably reach a speed of 0, just for like a split second at least? At what point do they have their maximum potential energy, maximum kinetic energy, etc.? All right. Secondly, here we have a energy graph, right? And this graph is showing kinetic energy in the green, potential energy in the blue, total energy in the yellow or gold. We just want to identify, does this energy graph match the skater in the picture above? And then just explain, right? Yes or no, and why. All right. So in that graph that we just looked at, how would you explain what's going on in the graph, right? You might want to look at what's happening in each axis and what type of energy is being graphed. Now, using that same graph, what can you say about what's happening to the total energy? Okay, finally, we have a little loop-de-loop track, which if you followed the challenge in the previous questions, you could have created yourself. Assume that a rider is able to go from point A all the way to point 3 and back. At which point would the total sum potential energy and kinetic be the same? Using that same diagram, assume the skater starts at point 1, goes to point 2. What type of energy transformation would happen, right? What would they start with? What would they end with? And why? That's it. All right, pretty simple lab. I really encourage you guys to just kind of spend your time playing around with it. Create some different tracks, kind of see how those energy transformations work. If you want to get a little crazy with it, you can also change the mass of the rider, see what happens there. You can start adding friction, see how that affects the type of energy that exists in these energy transformations, and then see what's the most realistic. All right, if you guys have any questions, feel free to shoot me an email.